I'm Anil Kumar, and in this particular video, we will understand how trigonometry helps us to solve real life situations. I'll actually begin with very simple examples and will develop great concept. So let us assume that this is a ground, and on this ground somewhere we have a flagpole, right? So this is my flagpole. My idea is to find height of this flagpole, right? So I just watch and I'm going by and I get curious to find the height of this flagpole. So how can I find that? So that is the question, right? So we have this flagpole here, right? So we need to find the height of this. So what I do here is that I take 10 steps, let us say, and let me sketch the scenario so that it becomes easier. So I take 10 steps and I observe that I am straight in the line of the sun, and that matches with the shadow, let us say. So what I find here, that once I take 10 steps, I am in line with the shadow of this particular flagpole, right? So basically what we have situation here is that there is sun here, right? So because of that there is a shadow. Now this shadow is 10 steps away. Now I make my guess of the angle, and this angle seems to be about 40 degrees. So we have an angle of 40 degrees, and we say, well, knowing that the angle is 40 degrees, what could be the height of the flag? So what we say is, let's use trigonometric ratios. Okay, so let me hold on my calculator now, since I've taken such an angle, which is not one of my special angles. Okay, so what we know here is that these are my 10 steps and the height is related with these 10 steps. So height is the opposite side of the angle given to us. So in this particular case we know opposite side, and we also know adjacent side. Since we know opposite and adjacent, I can use tan, right? So know tan of 40 degrees, which is opposite over adjacent. Let me write here, opposite over adjacent. So I know tan of 40 degrees is h over 10. And from here, cross multiplying, I get h equals to 10 times tan of 40 degrees. Correct. So we can use the calculator now to find the angle. So it is 10 times tan of 40 degrees. So that gives us angle of 8.39. Okay, so we get 8.39. Let me write 8.4, and let me say steps is let's say steps. Okay, so, or we can call it in feet. Okay, so let's say feet per feet. So that is so many feet. So normally we don't use feet in our units, but since I started with steps, let's use them. Okay, so it is 8.4 feet for us. So that is 10 feet, and the height is 8.4 feet for us. Like, doesn't look like, but you know, we just estimated that angle to 40. Okay, so what we know here is the height. Now the idea is that there is a lot of wind, so what we decide is to provide it a support. So let us say we provided support to our flag, and with that support, let me now give a support to this flag. So what we did was we just gave a support here with some, that is the support here, right? Now when this support was given at that time, we noticed that this point is, let us say this point is, since this is 10, we'll call this as 6 steps away or 6 feet away, right? So it was hinged right here. Now what we want to find is the length of the support. So how do we find length of the support now? Well, in this particular case, we know that the angle which the flag makes with the ground is perpendicular, and now we have calculated h as equal to 8.4, right? So h is 8.4 for us, and we know this is 6 feet, so we can find the length of the support also. How can we find it? Okay, so length of the support you could find either using uh, Pythagorean theorem or trigonometry, right? So in this particular case, it is better to use Pythagorean theorem, right? So length of the support L is equal to 6 square plus 8.4 square root, right? So we found the length of the support. Let's calculate this. So we have square root of 6 square plus 8.4 square equals to, it gives us some unit, less decimal, 10.32. So that is equals to 10.32 for us. Okay, so we'll round it to 10.3. So this length of the support is 10.3 and the units for us is feet. Now in this particular case, if I have to find the angle which this support makes with the peg here, then how do we find that angle? To find this angle, we can use tan of theta, right? So let's say that this angle for us is theta. Then theta opposite side is 8.4 and this is 6 for us. So we can say, well, tan theta is equal to 8.4 over, which is the opposite side, over the adjacent side, which is 6. So theta could be written as tan inverse of 8.4 over 6. So we can again use our calculator and shift tan inverse and find the ratio. 8.4 divided by 6 equals to, so that gives us 54.46. So this angle is 54.46 degrees. So let's round this angle to 54.5 degrees. So we know that angle is 54.5 degrees. Now this is a particular example in which we have right triangle, we have acute angles, right? And so it was very easy to solve using the tan ratio. So you can say this is how we can actually use tangent ratios, right? So we use tangent ratio to solve our question. Now, if I kind of complicate the situation, that is to say that if I say that I want to give another support to this flag and this is on that side but it is on the ground, so this is all the ground, right? So we'll make a 3D kind of a figure providing it a support right there. So you can see that this place is again on the ground, correct? So what I'm trying to say here is, let me just show you the plane. That is the ground for us, okay? So this is all the ground. So it is still on the ground, okay? But we have pegged it from the top of the flag to a point elsewhere, right? So now this forms a triangle which is not an acute angle triangle. You see that part? But still, since we have this particular post, you can always support it anywhere around on the ground. Do you get it? Now what we get here is a different angle. And let us say the angle with previous support and this angle is, let us say, 120 degrees. Now my question is, how do you find the distance between the two pegs? So that means the first one which we had placed here and the other one. So what is the distance between these two? What is the distance between these two pegs? Now that is a big question. How to solve such a question? That is what takes us to different level of trigonometry. So one, we are trying to understand what happens when the angles are not acute angles. Third, we are trying to solve triangles which are not right triangles, right? So that takes us to our applications number 2. So in applications number 2, we'll try to understand how to solve such questions where the angles involved may not be 90 degrees and not even the acute angles, right? So in such cases, we may use few laws which we know as sine law, cosine law, and other trigonometric ratios to solve. So that is what we are going to explore in the next video. I hope that helps. Thank you and all the best.